All right, so in this chapter, we're going to start learning about significance tests. And before we really get into significance tests, we really have to learn the basic principle that significance test is built off of. And this all comes down to what's called the null hypothesis. Null hypothesis. Looks like my marker is about to run out. The good things I got a backup one. Null hypothesis, or HO, or HO, for short, your null hypothesis. So let's kind of talk about what a null hypothesis is. So let's say that you're on a basketball team and you're in the middle of a game and coach is asking all you guys like I need the best free throw shooter to go in because this team is going to be super physical and I know they're going to foul you a lot. So of course he wants to have the best free throw shooters in the game. And then you raise your hand and you tell him, yeah, I'm 80% free throw shooter, coach, put me in. And he's like, all right, you're in. And then you go in the game and it ends up being just like he said. You end up getting fouled like over and over, and you end up shooting 50 free throws, but you only end up making 32 out of the 50. So you only end up making 64% of them, or 0.64. And that's not 80%. You said you can shoot 80%. In other words, your null hypothesis, we say, is that P, or your true proportion of made free throws, is 0.8. That's what you're claiming. That's why he put you in the game, because you claimed that your free throw proportion is 0.8, but you only made 64% of them in the game, and you guys ended up losing. So he's a little, disappointed, but he probably will give you the benefit of the doubt because, of course, you probably maybe say, well, I just had a bad game, and teammates are probably, yeah, he probably just had a bad game, and coach is like, okay, maybe you had a bad game, maybe it happens. But then you start thinking, because your coach actually took AP stats class in high school, and he actually knows how to conduct significance tests. So he's like, all right, I'm gonna actually conduct a significance test to see if the true value of P would be 0.8. Is the true proportion 80%? And is it reasonable to get a sample proportion of 0.64 at an alpha level of 0.05 and so forth, blah, blah, blah. And then that's when you guys, just kind of blank out. And it's usually when my students start, like staying quiet and like what's going on? What is he talking about? So let's kind of get into like what he's going to do. So what happened here is that we got a sample proportion. Your sample proportion was 0.64, right? 0.64. And it's kind of like a trial. You shot 50 free throws and you got a sample proportion of 0.64. And again, it's possible, right? It's possible to get a sample proportion of 0.64 even if the true proportion is 0.8, right? Now, this is the null hypothesis, and the counterclaim would be what's called the alternative hypothesis. The alternative hypothesis goes against the null hypothesis. The alternative hypothesis, we go HA, that's your ha. So we have your ho versus your ha. And your ha would be that P is less than 0.8. So these are your hypotheses. Their null hypothesis, your ho is that P is 0.8. Your alternative hypothesis, or your ha, is P is less than 0.8. So now we have to kind of find a way to show that either this is, reasonable to think is true, or that this is reasonable to think is true. Is this more reasonable to believe, or is this more reasonable to believe? And that's where significance tests come in. So your coach, comes back from his laboratory or whatever, his office, or his his cubicle, and he starts sits you guys all down. He's like, all right, guys, I did some calculations, so let me show you what I got. I got my sampling. I did this a simulation of 400 trials. And you're like, 400? What are you talking about? 400 trials. And let me show you what I got here. So he draws his number line. He starts making these dots. He starts putting these dots like, all these dots. And I'm not gonna do them all, but he ends up getting like 400 of these dots, creating some like, almost like normal distribution, some pattern, not quite, but again, this is just a sketch. Ends up getting all these dots. Now, let's first make sure we know what these dots mean. Each of these dots, let's just pick one. Each of these dots represents the proportion of made free throws if the true p-value is 0.8. If you took 400 sets of 50 shots, 400 sets of 50 shots, and we got a p hat of like 0.8, 0.82. We got another one of 0.78. We got another one of 0.8, and so forth. We got 800 of these or 400 of these. All these represent the different sample proportions we got from 50 shots that each of these took. And he's like, okay, well, you only made 64% of them. So he's like, see, based on my simulation, let's go into detail here. So let me show you. So here, this is that would be like a 0.62. This is a 0.64, 0.66, 0.68. And he's like, out of all those, there's only four out of the 400 dots, only 4 out of the 400 dots were less than or equal to 0.64. So then he says, well, based on this, the probability of getting a p hat less than or equal to 0.64 is 4 out of 100 or 1%. So 4 out of 400, 1%. So he's like, I think you're lying. I don't think you should really shoot 80%, because based on my significance test or simulation, 1% of the time we got p hat values of 64% or less, or 0.64 or less. And you're kind of scratching your head, and this is usually when my students are scratching my head, not trying to draw attention to themselves. They're trying to figure out what I mean by this. But you have to think now. Let's think for a second. Like what's going on here? A simulation. The simulation for this would be, instead of actually physically having someone shoot 50 shots 400 times, maybe 50 shots a day for 400 days and recording the proportions, we have a computer. Do a simulation. If you remember from the previous chapter when we sampling distributions, that all this comes from that idea. Now we think, out of those 400 proportions, 4 out of the 400, only 4 of them had a value of 0.64 or less. So it's saying that if we assume that this is true, we're saying that this is true, this is the truth. We start with our null hypothesis. We start with our HO. We assume the HO is true. We assume the population proportion is 0.8. We assume it's true. If this is true, what are the odds that you're going to get a sample proportion of p hat being less than or equal to 0.64? What are the chances, if this were true, what are the chances that you would get this? What are the chances that you only make 64% of your free throws? And based on our simulation, the chance of that happening is only 1%. So that's what we call our p-value. This is our p-value. We got a p-value of 1%. And our p-value is so low, our p-value is low enough. So then what we say is we're going to reject HO. We're going to reject the HO. Reject HO because we got a p-value that was so low that it's low enough for us to be like, yeah, this is not going to happen by chance. This is not going to happen by luck. It happened because this ain't true. It's not true that the true proportion is 80%. That ain't true. That's why you got a value that low. Now, the argument is it's always possible theoretically to get a value of this low. It's just very rare. 1 out of 100 times it would happen. So it's possible, but we have basically reasonable evidence, reasonable doubt to believe that is actually the truth. And we're going to go more into this in the next part of this section, but we start with what's called, before we decide when we're going to reject our HO, we come up with our alpha level, our significance value. We say significance value. That's not how you spell significance. Significance. I can spell it. Value alpha. That's your alpha. And usually we make alpha 0.05. We usually make alpha 5% or 0.05. And we say that if we're going to get a p-value less than our alpha, we reject our HO. We're going to reject our null hypothesis. If we don't, then we're going to basically say, okay, well, I guess it's possible that the null hypothesis is true. But we have to decide this first before we look at our data and figure out the p-value. So this is the main idea behind all significance tests for proportion, and we're going to look at significance tests for mean. But make sure you really understand this because really the rest of this chapter is pretty easy because this is the logical part. Logical part to really take your time with this, and I'm going to go more into this in the next part of this section. All right, so good luck. I hope that helps.